Okay, today we're going to continue talking about our properties of exponents, and we are going to work on the power of a quotient property first. We have three we're going to do today. Basically, we've done this before. This is very, very similar to the power of a product property, where what's outside the parentheses goes to every base inside the parentheses. So for this one, if I have the fraction a over b, all of that to the mth power, basically this just equals a to the m power over b to the m power. And again, this is very, very similar to a property that we've already done. Let's just do a couple of quick little examples. Example 1, let's do c over d to the 5th power, which is going to equal c over d. What's the exponent understood on the c right here? That's a 1. What's the exponent understood on the d? That's a 1. And if this is to the 5th power, then now we have a power raised to a power. 1 times 5 is 5, so it's c to the 5th over d to the 1. 5 times 1 is 5, so that's d to the 5th. Okay, let's have a little bit more b in here. So let's do example 2. Let's have x squared over y cubed, all of that to the 4th power. So this is the same idea, where if we have a power, the 4 goes to every base inside the parentheses, and a power raised to a power we multiply. So this becomes x to the 2 times 4 over y to the 3 times 4, or more simply put, x to the, whoops, that should be a 4, not an 8, x to the 8th over y to the 12th. There we go. So again, it goes to everything inside the parentheses. Now for the 0 exponents, also this one right here, this one we just did, is on your formula chart, I do believe. This next one is not on your formula chart, but let's talk about what it means and how it works. So I'm going to use the example of x to the 5th divided by x to the 5th. So if we use our division property of exponents, if we divide like bases, we subtract the exponent. So this becomes x to the 5 minus 5, and 5 minus 5 is 0. So that's x to the 0 power. Okay, so that's one way we can get a 0 exponent. But what does this really mean? If we go back right here, any number over itself always equals 1. 2 over 2 reduces to 1. X over x reduces to 1. X to the 5th over x to the 5th also reduces to 1. So x to the 0 power equals 1. So what goes with this is for any non-zero number, whoops, I didn't mean the comma there, any non-zero number to the 0 power equals 1. It has to be a non-zero number if you're dividing, because you can't divide by 0. Dividing by 0 is undefined, so any non-zero number. So an example of this is going to be, even 0 to the 0 power is undefined. You can't divide by 0. So the example we're going to do with this one is going to be in parentheses 2x cubed y, close parentheses, to the 0 power. Anything to the 0 power equals, you got it, 1. So if it's something like that, that's super easy. Now with all of these, you're going to be simplifying and doing different things within problems, particularly as the problems get more complicated. So just be careful, take everything one step at a time, make sure you're following your properties and or your order of operations. And all will be right with the world. Okay, so for the last one we're going to do today, which is the negative exponents. This one is on your formula chart. And what your formula chart says is a to the negative n power equals 1 over a to the nth power. So if we look at this, two things have changed. Number one is here is a is by itself. You could think of it as being over 1. And so it's kind of the reciprocal or the inverse. But then also the negative exponent became positive. So let's look at another example that's similar algebraically. So we have a to the negative nth, or 1 over a to the negative nth power. And that's going to equal a to the nth power. So basically, if you have a negative exponent, move it to the other side of the fraction bar and make the exponent positive. So if it's underneath, you move it to the top and you make it positive. So I do want to write the word inverse down here. You need to be thinking about inverse. In other math classes, you'll hit the word inverse a lot harder. But hopefully it won't be a shock or a surprise when you see it, because we are going to talk about inverse a fair bit this year too. So let's write down some negative exponent stuff. So negative exponents. For negative exponents, you move the base and its exponent to the other side of the fraction bar. And change the sign of the exponent. Oops, there we go. Sorry about that. Change the sign of the exponent. So let's go ahead and do an example here. Hang on just 1 second. There we go. And then my phone went off too, so it'll stop in just a second. Okay, so let's go ahead and do an example for negative exponents. Sorry about that. It's still not stopping. For example 1, going to check this phone again. There we go. Let's do x to the 4, and this goes with our negative exponents. There we go. So let's do x to the 4th, y to the negative 2, over x to the negative 4, y to the negative 3. Now I can think of two different ways to do this problem. So why don't you pause it, and then then when you come back, we'll do it both ways. Okay, so let's see if you got the same thing. First way I'm going to do it is I'm going to think about it just as straight up division, dividing exponents. When we divide exponents, we're subtracting them. So on the top we have x to the 4th. Then on the bottom we have x to the negative 4, so it's going to be minus negative 4. Then if we have negative 2 on the top and negative 3 on the bottom, so it's going to be y to the negative 2 minus negative 3. Now whenever we're minus a negative, that becomes plus a positive, plus a positive. So in this case, this is going to equal x to the 4 plus 4 is 8. Y to the negative 2 plus 1 is 1. If it's 1, you don't have to put it. So x to the 8th y is our answer there. Now another way to think about this is actually using your negative exponents. And so let's do that. So let's look at the negative exponent. Negative exponent tells you to move it to the other side of the fraction bar. I'll put a squiggly line as we do it the other way. So on the top here we have x to the 4th. Then this x to the 4th down, negative 4 down here means we move it to the top and make it positive. So it's going to be x to the positive 4 up there. Here we have y to the negative 2. A negative tells us to move it to the other side of the fraction bar and make it positive. So it's going to be y to the positive 2. And then y to the negative 3, we can move it to the top and make it positive 3, so it's going to be y to the positive 3. So now I just made all of my negative exponents positive. And so now let's simplify this. So x to the 4th times x to the 4th is going to be, we add the exponent, so that's x to the 8th. Y to the, when we divide, we subtract, so 3 minus 2 is 1. So it's 1, you don't have to put it. There we go, we got the same answer both ways. There is only one more thing that I want to add, and this becomes extremely important. And that is when you simplify and you're dealing with exponents, there can only be positive exponents. So if the instructions say simplify, you can only have positive exponents. Now sometimes I've seen it as write this fraction as only a numerator, and therefore if you have a positive number down here, you have to move it to the top and make it negative. So things like that can happen. Please work on assignment number 3. If you have any questions about it, please let me know, and I'll be talking to you soon.